Okay. All right, so if any more turn up, I'll let them in. But okay, so this is chapter 3 from your book on polynomials. Okay, so just a bit of information about polynomials. You've actually seen these before already, but you probably don't use this word. Okay, so if you were to write out a polynomial, it's in the form like y equals, well, let's do the simplest polynomial. For example, y equals a, some number. So, for example, y equals 2, y equals -3. So this is the most simplest polynomial you've probably seen. And we can graph these. So a simple polynomial would be y equals 2. So we mark 2 here. This is your y-axis, right? But we're not going to really do much on graphing this in this section. I'm just showing you what they look like if we were to graph them. So this is 2 here, y equals 2, and that's the equation or the line y equals 2. All right, that's the easiest polynomial you're going to find. Another one, y equals -3. So that would be down here, y equals -3, if you're going to graph them there. -3 is the intercept. What you note then, that y equals 2 actually has x power 0 on it. That's x power 0. Because remember, any number to power 0 is 1. So 2x0 is just 2. Okay, so this is called the degree of the polynomial. And this is probably in your textbook, degree of the polynomial. Sorry, my handwriting's not good. Don't like this pen. Okay, that's the degree, D-E-G-R-E-E. So that's the easiest one you'll find. And that's called a constant polynomial. I need to make space here. So you can copy this if you want, but I think most of it's in your textbook anyway. So first one, constant polynomial. So that's the first one. Another one you'll get is still linear, but the line will be on an angle somewhere. So for example, once I clean that out, another example would look like this. And I'm sure you saw this in grade 8, right? Just a linear equation. So if that was 2 and that was -2, this would be the equation y equals x plus 2, like that. So this is a linear polynomial. And notice here the degree is 1. X is x power 1. So this is y equals a, some number, and linear could be written as y equals mx plus c, okay? And the degree is 1. In the constant, the degree is 0. I can put an x0 there. So that's a linear equation that you saw in grade 8, and it's called a polynomial as well. Okay, so that's why I said you've actually already seen these. So it's not really a new topic, okay? But I think you saw quadratics probably a bit last year. So another polynomial would be, number 3 would be a quadratic. I'll do them here. Quadratic polynomial. So a simple one would be y equals x squared. And if you were to graph that, it looks like this. Okay, just a basic quadratic. The degree is 2. That's your degree. So anything like y equals x squared plus 2x plus 1, the degree is 2. This is still a quadratic. All right, don't worry about the x power 1. We follow the highest power. Okay, so that gives the name. That's the quadratic. Number 4 would be a cubic. So the very simple cubic would be y equals x cubed. And that's what you're going to see down here. We're going to talk about these ones actually. So if you were to graph this, that would look like this. This is a very important topic in grade 10, which I'm just finishing the work with grade 10 for these graphs. So you'll learn how to graph them later on in grade 10. But today we learn more about factorizing them. Okay, so that's a cubic. So anything actually like another one, y equals 2x cubed plus 4x squared minus 5. That's a cubic as well, because the highest power is 3. Highest power equals 3. So it's a cubic polynomial. Cube is easy to remember, power 3. When you see a cube and you want area, x, or the volume, xxx, the volume is x cubed, isn't it? So it's easy to remember the name. It's a cubic polynomial. And lots of applications for this as well, which you'll learn a bit more later. Okay, so very important, we know how to factorize cubics. But we're doing certain kinds of cubics, not all. So this one here, you can actually, or maybe you can factorize that. I'm not sure. Maybe we can factorize this. I'm not sure about that. You could maybe write it in this form. So x plus 1, x minus 2, x plus 4. This is for grade 10. We do this in grade 10, these kinds of questions. Okay, but they can be factorized, some of them. But today we're more interested in, for example, something of the form a cubed plus b cubed. So for example, can you factorize x cubed plus 27? And we can factorize this. Even though it doesn't look like it's got any common factors, we can do it. And we'll learn how to do that now. So, and you'll see this again in grade 10, these kinds of problems. So in your textbook, they have some diagrams, cube diagrams. If you look in page 118, 119, and they use diagram to explain it, how this is working. But I think this is quite complicated for me to draw. So I'm not going to do the drawing method to show you how it's working. So I'll just do an algebraic method. I'll show you some algebra method, how to get the formula for the factorization. You can follow the diagram in the book yourself if you want to see how it's working there. Take a look there. Okay, so we'll try to factorize a cubed plus b cubed, this one. The first thing I do, I put in blue here, a squared b minus a squared b. And you should know that equals 0, doesn't it? Because they would cancel out because they're exactly the same. So these are equal. They're still equal. But I did that because now I can do grouping factorization. You see that? And that's why I taught you grouping last week, because we're using those methods today. So if you look here, you see a squared is the common factor. All right. And then you would be left with a plus b. The common factor here is b. So minus b, a squared minus b squared. Remember, the sign will change because of the minus here. Minus b squared is plus b cubed. So be careful on your sign. But now here, you would recognize that from last week. That's difference of squares. So let's do a bit more work. A squared, a plus b, minus b. And now you've got a squared minus b squared, which is a minus b, a plus b from last week. Like that. And now you will see you have a common factor, a plus b. You see that? So we'll take that out. So now we've got a plus b in the front. And you are left with a squared minus this. So a squared minus b, a minus b. Okay, so then we will just simplify this part. So a plus b, a squared minus ab plus b squared, and finished. Okay, so actually that is a cubed plus b cubed. And we did manage to factorize it. If you want to expand this out, you will check many things will cancel out. Okay, but you'll get back to this here. So that's your first factorization. Okay, so for the difference of cubes, I'll go up a little bit. If you're copying, I'll leave it there, but it's in your book too. So in this question, we're looking at the difference being subtraction of cubes, the difference of cubes. So all I did here was swap these two numbers around. I put the a minus a squared b in the front. Okay, so you can compare that to the first one here. See, a squared b minus a squared b. Now I put minus a squared b in the front. So what we do then, just factorize again by grouping. Now we have a common factor a squared. We'd be left with a minus b. Common factor here is b. And then I'd be left with a squared minus b squared. So now you see, that a squared minus b squared, we can factorize that. A minus b plus b, and then this is difference of squares. So that's a minus b, a plus b from last week. Okay, so now we see the common factor, which is a minus b, and then we'll take that out. So we've got a minus b put in the front. You're left with a squared plus b from here, and then the a plus b here. Where? And then we have a minus b, a squared plus ab plus b squared, and finished. That's the second one, a cubed minus b cubed. And again, if you want to check the working, you can expand this and you'll get back to here. Okay, so very useful for when we're graphing as well. But we'll learn more about graphing, especially grade 10. Now, these are your two rules. This is your sum of cubes. So this is the sum of cubes. This is your difference. So you're thinking, how am I going to remember this? Well, it's actually pretty easy. If you see your first term has plus in it, your first expression has plus, this sign will be plus, a plus b. And then if it's negative, it will be a minus b. The sign will be the same. So same. So we write s. Now what happens here? The sign will change to be negative. And this one changes to be positive. So that's the opposite. So we write O for opposite. And then what happens here? The sign becomes both positive. So all positive. So we write AP for all positive. So you think you can remember that? Same, opposite, all positive. And same, opposite, all positive. Like that. So the only thing you need to remember, this is not 2AB. So don't confuse it with this rule. A squared plus 2AB plus B squared. This is 2. This has 2 in it. So don't confuse it with the perfect square rule. So this will be only AB, okay, not 2AB. So don't put a 2 in there. And later on, we'll learn how to do questions like x6 minus 3, 9. Okay, when we have powers that are multiples of 3, 3, 6, 9, 12, 15, we can do questions like this, but we'll do this later in the chapter, okay? So don't worry about them too much yet. So here's some examples. I think these are the ones in the book. So you can look in your book and follow on. And I might do these a little bit differently than the textbook, but you'll get to end up with the same answer anyway. So what you need to be looking for is something cubed plus or minus something cubed. So you should write the formulas down until you get used to it. A cubed plus B cubed will be A plus B, so same sign. Then we go to A squared minus AB plus B squared. And then if you want to write it only once, we can make that a minus, put a minus there, and this will be plus, like that. So that would be for the difference of cubes in black. So in this question, we've got x cubed plus 8, and you know 8 is 2 cubed, which is good. So now we can put a 2 cubed in here. So your first line in working should be x cubed plus 2 cubed. So just change your 8 to 2 cubed, and then we can compare it to your formula in red here. So we've got x cubed plus 2 cubed is x plus 2 first. And then we've got a squared, so that's going to be x squared, minus ab, which is x2. I'll swap that around later. Plus b squared, which is 2 squared. Right, so if you're still not sure, you should write the formula underneath. So you've got a cubed plus b cubed is a plus b, a squared minus ab plus b squared. So if that helps you, you can write the formula underneath to help do it correctly. So you've got an x2 here, so you should make that 2x, I guess. So x plus 2, x squared minus 2x plus 4. So that's your final answer. So that's x cubed plus 8. Now, by doing this, this actually can help a little bit with graphing, but this is actually really easy to graph without factorizing. So you'll learn more about that in grade 10 about that. Okay, so in question B, notice you've got 64, and you know 64 is 4 cubed. So that's a good thing because now we can write it in terms of cubes. So we've got 64, which is 4 cubed, but this is x cubed. So I put the x and I make in a bracket. So remember the rule, A, B, M is A, M, B, M, like that. So very useful rule for doing these problems. Just make sure you put the bracket around. Minus y cubed. So you can see here, the A is 4x and the B is y from the formula. So we would write that as A cubed minus B cubed is A minus B. And so this is same, and then we go to positive, opposite sign. But now it's A squared, so 4x squared plus 4x times y, that's A times B. 4xy plus y squared, like that. So your final line should be 4x minus y, 16x squared plus 4xy plus y squared, like that. Any problems? Any questions? Okay. But they're in your book anyway. The work solution is there. But I may use less working than is shown in the example. So for this one, you see you've got an x4, but you also have an x here, which is x power 1. Shall I make that larger? I might make it bigger. It's got to 200, right? So x4, x1. So the common factor here will be x. So always look for a common factor first when you have like this kind of situation. So x is a common factor. This will be x cubed. So x cubed times x, you add the power, remember, so x4 minus 64, and the x has already come out. So we write 64 as 4 cubed, x cubed minus 4 cubed. So now we see we have the difference of cubes. So we have x minus 4, and then this will become x squared plus 4x plus 4 squared. Okay, so a minus b, a squared plus ab plus b squared. Then you're left with x minus 4, and then just change your 4 squared to 16. So when we have small numbers, we normally change the power to the whole number. But if you had 125,000 squared, okay, you can leave it like that because the number will be way too big to write out. It'll be many digits. So if it's a small number like 4, 5, 6 squared, you can write it as a whole number. Now this one here, 192 and 3, I think 3, let me check my answer key. 3 is going to be 3 times 64. Yeah. So if you look here, m and n are different, but you see there's a common factor of 3. So if you're not sure, you'll need to check with your calculator. Usually 3 will be the common factor, the smaller number. And this will end up with 64 m cubed plus n cubed. And the good thing about 64 is that it's 4 cubed. So 3, put your 4m in a bracket, and that will make your 4 become cubed. I have a drink of water. Talk too much. So the next term, 4m cubed. So that's going to be, what am I missing? I forgot to write down the initial factor, didn't I? I did that last lesson as well. So this is going to be, okay, so 4m, that's actually okay. 4m cubed, because I'm just not got to the formula yet. Okay, now we can do it. So 4m cubed minus n cubed is 4m minus n. Like that. And then this is negative, so now in here will become positive. So 4m squared minus 4m n plus n squared. Yeah, so you got to be careful with your signs when you're not paying attention like me sometimes. So 4m minus n, this will be 16m squared plus 4mn plus n squared, like that. Any problems? Okay. So we got a couple more, and then this lesson's going to go into tomorrow anyway, so you won't get a lot done today. And tomorrow, or today, I'll send you the worksheet, and then you can look at that a bit tonight, and then we might talk about that tomorrow as well. So look here, you've got a common factor, which is y. And so take that out. X cubed minus 125 And if you know your cubes well, 125 is 5 cubed. It's cubed minus 5 cubed. So that's your basic form for the difference of cubes. So y x minus 5. So bring the sign down, same. And then we go to opposite, x squared plus 5x plus 25. So I kind of skipped some of the step there, but that's your final answer. So some questions will have 3 parts, 3 factors. So y, x minus 5, and this part here. One thing about, before I forget, this part normally can't be factorized anymore with real numbers. So no further factorization needed. So for grade 9, you can stop here. When you get to grade 12 or university, we will factorize these further. But these can't be written like this, like x plus 2, x minus 1. So this is not possible. You can't write it like a product of 2 factors. So when you do these problems, just stop here, okay, at that point. But you'll learn more about that later, how to do that with what they call complex numbers. So in this question, the last example, the common factor, well, you've got a 7, you've got a 56. So why don't you try 7? Which is good because 7 times 8 is 56. 8x cubed minus b cubed, like that. So no other common factor. So now 8, you change to be 2x all cubed. Because 8 is 2 cubed and x is x cubed. So we just write this like that. So 2 cubed, 8, x cubed, minus b cubed. So now we have our form a cubed minus b cubed. So you'll have a minus b, a squared plus 2x, b plus b squared, like that. So same, opposite, and all positive. So 7, 2x minus b. So change your 2x squared to be 4x squared. You don't need the bracket anymore. So try to get rid of those. You don't need brackets here, do you? So write that as 2xb. And the last term is b squared, like that. That's your final answer. Again, you've got 3 parts. So, which is quite possible. First number, which is a constant. Then you've got a linear, like what they call a linear factor, and another factor here. So that's your final answer for that one. We got a bit of time. So with the other class, I just got them to do the first page. So if you've got your textbook, you can just work on question 1 to 6 here first. So just the first page, because tomorrow we can go into the second page. So you can open this in line and write on your notebook or your tablet or into your textbook, okay? But I'll zoom it down so you can see all the questions there. You can read them, right? You can read all of those. Okay, so just for now, do these 6 questions and I'll wait a little while and then we'll see about some answers. So work for about, shall we go through a few answers and see how you're doing? I'll make that larger. Too big. All right. So we got 10 minutes, so I'll go through a few and just check you're on the right track. So if you've got x cubed plus 1, remember any 1 value can be written as 1 cubed, like that. Okay, so no problem when you got 1. So we've got the form a cubed plus b cubed here, like that. And we know the rule, the formula would be a plus b a squared minus ab plus b squared, like that. So we can write it down as, let's use red. So x cubed plus 1 cubed, which is x plus 1, x squared because of the a, minus ab, so that's x1, plus 1 squared. So show me a little bit of working anyway, especially the harder problems. So x plus 1, x squared minus x plus 1, like that, finished. Okay, remember this last factor, normally that can't be factorized using the methods that you know at the moment. So in question 2, now it's the same except we have minus. So z cubed minus 1 cubed. So we're going to have z minus 1 as the factor. So then we've got z squared plus z times 1 plus 1 squared, like that. So z minus 1, z squared plus z plus 1, and finished. So not much difference between the two, is there? That's question 2. Question 3, look for common factors. Well, there's no common factor, but you know 8 is 2 cubed. So it's a good idea to learn your cubes. So 2 cubed, 3 cubed, 4 cubed, and so on. If you can learn them down to 10 cubed, it will make your life a bit easier, a bit faster. Okay, so 8 is 2 cubed, and I'll put that in a bracket, plus, and 27 is 3 cubed, like that. So we see we have the next step, which is the formula. So 2x plus 3, so same sign here. Then we've got 2x squared, then we change to negative. So then you got 2x times 3 plus 3 squared. So when you're doing your homework, you should show me this step here. Okay, don't just jump to the answer, which is the next step. So there should be basically 3 lines in the answer, 3 to 4 lines. So 2x plus 3, 2x all squared is 4x squared, minus 2 times 3, which is 6x, plus 9, like that. So simplify out your last factor there, down to that. And no common factors, nothing really you can do here for factorizing this part. So we stop. So question 4, we've got a 1, so we know that's going to be 1 cubed. The 64 is 4 cubed. That's why I mentioned that it's useful to learn some of these cube numbers here. Makes it just a bit quicker. So then you got 4x cubed minus 1 cubed there. So now you use your rule. So a cubed minus b cubed is a minus b. So same sign, and then we go to positive. But then we square a squared plus a b plus b squared, like that. So then we've got 4x minus 1. 4x all squared is 16x squared. 4x times 1 is 4x. And 1 squared is 1, like that. Okay, I'm going to send you the answer key in a couple of days, but tomorrow we'll be finishing these exercises. So today, you don't need to go past question 6. So just go up to there, because you want to have something to do tomorrow, okay? So you don't need to do it today. So in question 5, you notice you've got 3 and 3. So that's going to be a common factor. But also you've got x squared and x5. And remember x squared, x5 is x2 times x3 here. So x2 is a common factor as well, x2. So you would be left with x3. Remember, you add the powers, that rule. am times an is am plus n. Just to remind you, don't multiply the powers. So x3, 3 plus 2 is 5, plus 1, because the whole term has come out the front here, and you need a 1 there to fill that in. But now you know 1 is 1 cubed. So we'll put a cube there. So we've got 3x squared. Now you've got x cubed plus 1 cubed, so x plus 1. Then we've got this number, x squared minus x times 1 plus 1 squared. Okay, and then we just tidy that up. 3x squared, x plus 1, x squared minus x plus 1. So same sign, opposite sign, all positive. Right, so if you remember SOAP, you'll be clean and you'll know how to do maths too. Well, cubics anyway. So that's question 5. We got a few more minutes. So in this one, we've got 27 and minus 1. So the number won't have a common factor, but we have an x squared and we have x5. So you can take out x squared as a common factor. You'll have 27 minus x cubed, right? And 27 is 3 cubed, so we can change that again. 3 cubed minus x cubed. You don't have to have x as the first number. X can be second number or the first number, it doesn't matter. So then we've got x squared. 3 cubed minus x cubed is 3 minus x. Then we change to positive, but then we have a squared, so 3 squared, plus 3 times x plus x squared. So then you've got x squared, 3 minus x, 9 plus 3x plus x squared. That's your final answer. So notice that you will get, in some questions, 3 factors. This one, and this one in some questions, especially when you factorize at the start. Okay. So I think we'll stop there. Is there any questions?